landing gear to move or rotate about its axis. This axis about this about this axis. As you can see its shape, this is hollow from inside and has a circular shape from outside, so that it placed in this and landing gear can move around this about its central axis. As you can see, this is only a simple and small components. I have added one component and I have added one more component in this for today's lecture, that is cylinder piston, which is placed inside this cylinder leg, and ball joint is placed here, and then again a housing that we made yesterday will come up over this. This is cylinder leg. Here we have ball joint and that housing over that ball joint, and this piston plays inside this. Okay, so today we are going to make this piston and ball joint. So let's start designing these. First we make ball joint. After that we will make that piston. Start here part. Here we have loads of different components like sketchers, ship making, robots, ray tracing, open CAD, but we are making parts, or so we need only part design. Create body and create sketch. Let's take this plane. Okay, first we take this line. Okay, let's make some dimensional, or this is vertical. Let its length be 6 mm. Okay, then vertical distance is 3 mm. Make it symmetric. Here what we need is horizontal distance so that we can fix it with respect to center. Let it be 2 mm only. As we don't have dimensions, so we are just taking any dimensions here. 3 arc point, 3 point arc, end points of this line and this. Okay, but this is free to move. We can move it. This is the simplest way to make this. Here I'm making a little horizontal lines. Though we know that these are movable and not horizontal. First we make them horizontal like this. Then we will coincide these endpoints with its endpoints. Okay. Then this with this and this with this. Then making these two lines equal. This is sign of equality. And this is also look like equal, but this is parallel lines. This is for greater than or less than symbol. Uh, with this we can make something greater than or less than, which will always be greater than or always be less than to other one. Now I am giving some dimension to this. Right, yeah, to be 1 mm only to close. I still have 1 degree of freedom like this. This is free to move. Okay, we will give radius to it so that it won't move. Now it is all in green color and fully defined, fully dimensioned. No more dimensions are required here now. And placing dimensions which do not cut to each other. Clear dimensions like this. Okay, this is the one half, or you can say cut section of the ball joint. When it will revolve around this axis, it will give us a whole ball joint. Now close it, making it isometric so that we can see it here like this. Z axis already selected. Okay, this is ball joint, and that ball joint housing will placed here. That is, this ball joint will be placed inside the that housing. We have made that curved area that there, and the piston head will be placed here. This is the one way of making ball joint. We have another way by which we can make this. First, I you move this, edit my sketch, delete whole of the sketch, taking cylinder. Okay, let me give some dimensions to it. We have taken 6 that time. Let it be 6 only. This was 1, and let it be 4. Okay. Now these horizontal and vertical distances. Okay, 2, and here it is 3. Sorry, we have to take vertical distance here. This is 3. Close. Again revolve it. Close. Now taking it at this plane and sketch over it. Here we need this polyline. I'm taking it a bit away so that I can see what shape it is coming, what shape we are making out of it, making this vertical and that these two be horizontal. Okay, Here I will again take 3-point arc like this. Okay, I'm taking vertical distance of this point to the center B. We have taken it at 4 I guess. We have to fix these 2 points also. Okay, this distance uh, again this distance B here. Now what I will do, that close it. Now with this sketch I will make, you can't see groove. You have to edit this sketch like this. But this one is only effective if we have dimensions. You can see both of them are similar that we have made earlier and the one we have made now. The both are both when we have dimensions both will be look like same. And another thing, just difference is time and commands. In that one we use only one command, that is revolve command. In this one we have take used revolve as well as groove. Revolve means adding material, and this is similar to revolve, but it it will remove the material about that axis with the figure we have made. Okay. So previous one was better. Okay. Whatever we want, we can do it with this. Let me save this one. Right. Okay. Next, what we are going to do today is that this piston and cylinder leg will we will do tomorrow. The last component of the landing gear. Now from here we can see we have completed all these parts. Here we have tires, we have torsion links, we have ball joint housing as well as ball joint in it. We have drag strut 1, drag strut 2. This is pneumatic piston and cylinder arrangement. This is we have done. And here these four screws, that is avion special screw, we have done this also. So what we are left with, we are only left with these leg cylinder and leg piston, main cylinder or piston. So today we are going up with this piston, and tomorrow we will make this cylinder leg, the final and last part of the landing gear. So let's start making this piston also, which is also very simpler. Not much is there. Create part, here part design for that body, and for body there will be a sketch. I am taking XY plane. Okay, here we would need a circle for that cylinder. Then, but it is free to move. We need to fix it or keep constraints so that it won't move like this. And the radius, let it be 5 mm. Because this is the cylinder. Now I will pad it up to 100 mm. Let me see in isometric view. Zoom to fit so that, yeah, it's looking fine. This piston. Okay, but next I have to do this axle for the wheels. Okay, for that axle I will take ZX plane from origin. This is ZX plane, and here sketch. I will sketch in that plane. Zooming in, taking a circle and making it here. Okay, let's give some radius to it. That would be 5. Now this point and this point, horizontal distance 0. Okay, and again vertical distance would be, let it be 15 mm, or we can take it up to 20 mm. Fine, close this sketch. We will again pad it in symmetrical way, increase the distance to be 50. That is 25 is from at this side and 25 this side. Okay, now we get this. You can see this in this figure also, like this one cylinder and the axle. We got this one. Now this small part is left, which is similar to this one, and here you can see it. This which torsion link will join here and here, two torsion links and join together here. So for the torsion link we need that part. Let's do that also. That would be very a little bit complex to make, but we can make it easily. If you see this distance is looking much, then you can also edit this here. Zoom to fit so that I let it be 17, a bit lower and close. Now it is fine, looking fine. That part would be placed here. So again, I am taking ZX plane, sketching over it. I need it here. Here, this triangular part there would be and a hole between there. So for that, I am taking polyline like this, and this. Okay, making this one vertical, taking horizontal from center would be uh, 5 like this, so that it got attached to this. Let's make it 4.8 so that it merged with that, or we can also take it only 5. It would be again attached to that part. Now make these two equal so that we can have an isosceles triangle here, making it vertical distance. Let it be 12 only, and this length would be, let it be 4. Not 4, 4 is too less. 10. Yeah, 10 is fine, looking fine for now. As don't we don't have dimensions. If we have dimensions, if we would have dimensions, we could make that. Here I am going to take an, okay, so that it don't hurt while replacing this part to the engineer or maintenance engineer. Here let it be one only. To we have one degree of freedom, that is this one. So I am taking its center and horizontal distance 13 is coming out. Okay, it will be 13 only. Here one thing more we need, that is hole for the torsion link to join with this point and this point, vertical distance 0. Okay, so it will be in center. And again I'm going to radius be 2 mm. Okay, now 1 degree of freedom is again there, which is with this is in horizontal. So 7. Let it create only. We don't need to mesh set up 13, taking it a bit away so that I can place this 8 also there. 8, this 0 is no, 8, Okay, fine, fully defined and completed. Go out, pad it, it will make multiple solids here. So it is not spotted right now. So what we need to take another body. Okay, we will add a body here like this. Okay, for this body, that's exit plane and sketch over it, making it lower, and we'll sketch over this again as we have. I haven't deleted this sketch. If I have deleted, and it won't be shown here. Now it is showing I have an reference, so I can make a sketch over it. With here the radius would be 2. Okay, we can place it here. Now we'll make it a bit faster as we have some reference. But here we have committed a mistake by taking line, not a polyline. So don't worry, we have to just coincide endpoints of the lines, which we will do with ease. Now it is done by coinciding these points. The dimension of this line was 10 earlier. We take it 10, and sorry, vertical dimension was 12. Done. Here these two are equal. Okay, then this fillet command here on this sketch, this, and giving radius to this one would be 1 mm. Moving it here. So what we need to do is taking this point and horizontal distance are fixed. This point horizontal distance 13. This point and this point vertical distance. Here we have it. We'll pad it. It move out of the zone to put. Sorry, it would be symmetrical. It's showing 10. Let it be 10 only. Here we have this part. Here dozen links would be joined, and we have the We don't have dimensions, so I have taken it 10, but it would be lesser. It would placed in these boundaries, as you can see, like this. Okay, here we have all the this complete piston cylinder. This piston here, this piston will put into the cylinder leg. Here wheels would be placed, and here one of the torsion link would be attached, and other torsion link would be attached to the cylinder leg, and both are attached to each other so that it don't rotate inside the cylinder while landing or while takeoff. Okay, now we have done all the parts of landing gear except one, that is cylinder leg, which is also similar to this one and has not much difficulty in making that. We will complete it tomorrow, and tomorrow we have completed all the parts of this landing gear, and after that we will start some other topic or some other thing. Okay, here you can see in the segregated parts. Tires we have done torsion link. First we make torsion link, then we have this piston and cylinder arrangement, then we make these two drag struts. After that we make avion and tires. I'm saying tire not, but we have made wheels and these avions. Yesterday we made ball joint housing. Today we have made ball joints and this piston. The only thing which left is this cylinder leg. That is main landing gear. These two are the main things of the landing gear, which take 60 to 80% of the load. This piston cylinder arrangement and wheels are also attached to it, and other are supporting links. So tomorrow we will make this cylinder and we are complete up with this landing gear. Okay, thank you for thank you. That's all for today.
Thank you, sir. Thank you.
Thanks.